In this video, we're going to take a look at Venn diagrams and two-way tables and how we can calculate probabilities using these two things. So in this first example, we've got a survey of students who either like maths or don't like maths, or they like English or they don't like English. So they've been asked whether or not they like English and maths, okay? And there's a couple of gaps missing in my table, so I'm going to have to work out how to fill those in. Now, what we need to understand is that in this, across the top here, I've put in like maths and don't like maths. So if I read down here, this box tells me the amount of people who like maths and like English. This one tells me the people that like maths but don't like English. And this tells me, the 33, how many people like maths in total. Okay, so basically this splits the liking maths into two groups. Either they like maths and English, or they like maths and they don't like English. So that means if there's 33 people altogether that like maths, that means there was 5 of them that don't like English as well, because those two numbers have to add to 33. Okay, now this box here is people who don't like maths but like English. So the way I can fill that in is if I read across, my total has to be 61. So all of the people that like English, there's 61 of them. Okay, so if 28 of them like English and like maths, then we have to do 61 minus 28 to work out this number here. And so the amount of people who don't like maths are 33. Okay, so that's people who don't like maths but like English. Okay, now this number represents the number of people who don't like maths and they don't like English, so they don't really like much. So altogether, this column will tell me that there are 67, so if I add those two together, 33 and 34, 67 people who don't like maths in total. And then this number here tells me the total number of people who don't like English, which is 39. Okay, and this number here is really important because that tells me how many people were in my survey. And those two need to equal 100, and those two need to equal 100. So let's check. 61 plus 39, that gives me 100, and 33 plus 37 also gives me 100. Now, we're going to calculate the probability of different things happening using this two-way table. So the first one here has a P for probability and then in brackets an M. So that's what's the probability that someone likes maths? Okay, so how many people like maths in total? That's 33. And how many people did we ask? 100. So the probability that someone likes maths is going to be 33 over 100. Okay? Now this here, because we've got the E with the dash on the top, that's the amount of people who don't like English. Okay, so let's look at how many people don't like English. So we've got 5 and 34, so 39 people don't like English. So the probability someone doesn't like English is 39 out of 100. Okay, what does this mean here? This, remember this upside down thing, means and. So this is the probability someone likes English and likes maths. So where can I read that on the table? That is right here, this number 28. So 28 people like English and they like maths. So 28 out of 100. And that one I can simplify to give me 7 out of 25. So it's good to simplify your fractions if you can. Okay, now we're going to look at how we might use a Venn diagram to display the same information. In the Venn diagram, I've labeled them M and E. So M for maths, E for English. So I'm really just concerned with how many people like maths, and I want that, the total of this circle, to be how many people like maths, and the total of this circle is how many people like English. Now in the middle, so that intersecting bit there, that is the number of people who like both English and maths. So when we fill in a Venn diagram, we always start with the middle or the intersection of the two circles. So how many people like English and maths? We know that is 28 people. Okay, so over here is how many people just like maths, not English and maths, but just like maths. And that will be this number here, 5 people, because these 5 only like maths, they don't like English. Okay, same case on this side. Now we want the people who only like English, but they don't like maths. So that is this number here. This is the people who, oh, sorry, I'm wrong. It's this one up here. So this is the amount of people that like English, okay, but they don't like maths, so 33. Okay, so that's how we fill in our Venn diagram. Now, because let's take a look at maths here. If I was just looking for the probability of maths, I would need to add these two numbers together because all of these 28 people and all of these 5 people, they all like maths. Okay, so 33 people altogether like maths, and we know that already. Okay, that's what our table told us, so we know we're right. Now we need to somehow account for the people who don't like anything, because in the circles we've only got people who like maths and who like English. So outside here goes the number of people who don't like anything. So they don't like maths or they don't like English. So where can you find that in the table? Okay, that is that number here. These guys here, they don't like maths and they don't like English. So I've got 34 people who don't like English or maths, so they go outside of the circles. Okay, now the way you can check that you got the answer or that you've made the Venn diagram properly is all of these numbers, 5, 28, 33, and 34, they should add up to the total number of people in our survey in this case. So if I add 5 plus 28 plus 33 plus 34, I should get 100 total. So let's just check that. 5 and 28 is 33, plus another 33 is 66, plus 34 equals 100. So I know I've done it right. Okay, so that's how we set up a Venn diagram from a two-way table. Let's look at another example. Okay, in this case here, what I've done is I've just given you the words and we're going to fill in a Venn diagram in a two-way table from scratch. We'll look at the probabilities at the end. So this one is a survey conducted of 50 people about who likes coffee. I'm just going to underline that because it's coffee, and who likes tea. Okay, and we've got 50 people in total. So it was found that 20 people like both, 15 people only like coffee but not tea, and 10 people liked tea but not coffee. Okay, so let's see if we can fill in our Venn diagram. First, we need to label our circles with what we're actually measuring. So we're looking at who likes coffee, so I'll put a C here, and who likes tea. Now, like I said, always start with the middle. That is the people that like both. Okay, so in this case, 20 people liked both, so I'm going to put 20 in the middle. Now, the next bit of information I got was 15 people like coffee, but not tea. So that's these 15 over here. Okay, so they like coffee, but they don't like tea, so they're not in the tea circle. And then it says 10 people liked tea, but not coffee. So 10 people like tea, but not coffee. Now, what we're not told is we don't know who doesn't like either of them. Okay, and that's, remember, the number we have to put outside. But I do know there was 50 people who were surveyed. So this has, all the numbers in my Venn diagram have to add to 50. So 15 and 20 is 35, plus 10 is 45. So I need another 5 to make up my total of 50. So that means 5 people don't like coffee or tea. Let's see if I can now do the Venn diagram with this information. And I'm going to use the symbols that we use in maths because I'm a bit too lazy to write out all the words. So we either looked at people that like coffee or they don't like coffee. And then we had people who like tea and people who don't like tea. And then the bottom row is the total, and then the last column also gives us some totals. Okay, so in this square, I need to put the amount of people that like both coffee and tea. So that was that middle, the intersection of the two circles, this one here, 20 people. Then I need, okay, let's go across this way. So these are my tea drinkers. The people who like tea but don't like coffee. That was this number here, so 10 of them. And so that means I've got 30 tea drinkers in total. Okay, let's look at the coffee drinkers. So I'll go down this way. So I've got 20 people again that like coffee and tea, but what about the people that like coffee and don't like tea? That's over here, 15 of them. So altogether I have 35 coffee drinkers. Now this square tells us the people that don't like either. Don't like coffee, don't like tea, so that was 5. That was that number here. So altogether, if I look at this column now, I've got 15 people who don't like coffee, And if I go this way, I've got 20 people in total who don't like tea. Now, my two totals should match. 35 and 15 is 50. And checking that row, that column, sorry, 30 and 20 is also 50. So that must be right. All right, let's see if I can calculate some probabilities now. So the probability, this means that someone likes tea. Well, how many people like tea altogether? That was 30. So 30 out of 50 total. So that simplifies to 3 out of 5. So the probability that someone likes tea is 3 out of 5. Okay, now what about the probability that someone likes someone likes tea and coffee? The tea and coffee was the middle bit here, 20 out of 50. Or I can simplify that to 2 out of 5. Now this, the U shape, means what's the probability someone likes coffee or tea? So they could like tea or they could like coffee. And that is going to be this plus this plus this, because these are all the people that like coffee or tea. So 15 plus 20 plus 10 gives me 45. That should be out of 50 total, okay? So 45 people out of 50 like tea or coffee. So that simplifies to 9/10, okay? You might have also seen that you could have done 1 minus 5 out of 50 because you could have looked at the people that don't like coffee or tea. Okay, so you might have seen that already. Okay, so that's the end of this lesson. So we're just looking at how to put numbers into a two-way table and a Venn diagram, and then how to read the probabilities off of them.